Hey, it's Jacques in the Exercise Design Lab. Today I want to talk about two versions of the dumbbell chest press. A full range of motion version, right? And another version where we're limited to 90 degrees of horizontal abduction and 90 degrees of elbow flexion. And I want to understand this from the nervous system's point of view. In other words, how does the nervous system recruit the pectoralis major, the anterior deltoid, and the long head of the tricep as I go through those two different versions of the same exercise? Only if I've collected that information can I then make a determination about what might be better for one person. That's the person doing it, that's me. So I'm not making any sweeping generalizations about which is better, but I want you to see that there is a difference between doing the full range of motion dumbbell chest press versus the 90 degrees of abduction and 90 degrees of elbow flexion version of that dumbbell chest press, okay? So to collect this data, we're going to use surface electromyography. And so what I have is a Delsys called a Galileo sensor, and this is going to allow us to look at individual motor units in the pectoralis major as we go through both of those exercises. We're also going to have the more traditional Delsys EMG sensors on my anterior deltoid, and the other one's going to be on the long head of my tricep. Now, what's cool about these EMG sensors is that not only do they collect information about how the nervous system is stimulating that muscle to generate force, but it's also giving us accelerometer data. In other words, where is that sensor in space? Okay, we'll talk a little bit more about that. Now, the other thing I'm going to be collecting information on is the metabolic activity within those tissues, okay? So we're going to use something called near-infrared spectroscopy, right? This MOXIE monitor to monitor the utilization of oxygen within the pectoralis major, the anterior deltoid, and the long head of the tricep, okay? So we'll be able to see the rate of oxygen utilization as we go through those different exercises, all right? And we'll be able to see all this information within the same software. It's pretty cool. So let's dive into it, okay? Let's check this stuff out. Here we go. Okay, so just to remind you, I had a probe on my pectoralis major, anterior deltoid, long head of the tricep, both for the surface electromyography and also for the oxygen utilization data. We'll talk about some other data that sensor can collect, but we'll get to that momentarily. So what are we looking at here? I want to direct your attention to this part of the screen, down the very bottom row. You see those three rows? I want you to go eyes all the way down at the bottom. This is the accelerometer data for the long head of the tricep. Now, the reason why I'm showing this data is watch this. If I put a sensor on my pectoralis major, as I'm going through this motion, the pec isn't moving very much through space, right? It might be like undulating a little bit, you know, as I squeeze the muscle, but it's not really moving that much. If I put a sensor on my anterior deltoid, it's moving a bit more, right? A little bit more. But if you look at the sensor, if I put it on my tricep, it's moving the most around that axis, okay? And since it's moving the most, that is going to be the data that is going to help us to understand the motion the most clearly. It'll be able to see big undulations. And sure enough, if we look at the y-axis for this long head of the tricep, can you see how we've got this nice undulation down and up? And what's really cool about this is that each one of these humps represents a specific phase of the contraction, whether you're doing an eccentric or going through the concentric phase. So in this scenario, this up part, this happens to be the eccentric motion, and then right there, that's where you turn around, now it becomes concentric right there, eccentric, concentric, eccentric, concentric, right? So we could count each one of these humps, knowing that from valley to valley, from there to there, that constitutes one full rep, right? So I could count each one of the humps and I'd know how many reps I've done in this particular set. Now, this was my warm-up set, but I did go to pretty darn close to failure with a lighter load. I think it was around 65 pounds. I tried to keep the pace pretty even, as you can see, by looking down here. Just keep your eyes down here. Don't look at those other two things just yet, right? We're just looking down here, all right? So again, we can see that this is the eccentric phase, that's the concentric phase, eccentric, concentric. The other thing that I've done here is I've actually created little intervals in here where I have the eccentric and the concentric portion shaded, okay? So I'm gonna show you what that looks like. I'm gonna show you the first eccentric phase that I'm gonna look at is this one right here, okay? So what I'm gonna do is I'm gonna show you how I can shade that And we're gonna plot that like this. Watch, you're gonna see this little block of color, like it kind of highlights it. See that? That purple part kind of shades it right there. Okay, so that is the eccentric phase. It's going from the top position all the way down to the bottom. And this is, in this warm up, I'm just doing the 90-90 thing, okay? I'm just doing the 90-90 thing. Now, take your eyes up to the next level, right? This is the surface electromyography, the raw signal for the pectoralis major. And as you can see here, as I'm looking from this side over here at time equals 0, all the way up to, what is that, a little bit over a minute, maybe a minute and 5 seconds, right, 65 seconds, that there it gets bushy and then less bushy and then less bushy and then bushier and then less bushier and less bushier and bushier, right? You see this pattern happening over and over again. And in this purple section, right, which happens to be the first eccentric phase, that's one of the less bushier parts of this line, right? So on this eccentric phase, we have a little bit less bushiness, and you guys should know this, that on the eccentric phase, there's actually less force, right? There's less force being generated by this tissue because it is lowering the load. And depending on what happens when you get down to the bottom, the rate of lowering it, right, and how quickly or how slowly you stop that load at the bottom, that is going to influence how much force you have to generate. But as you can see right here, there's a lot less neuromuscular activity right there, okay? Now, I'm gonna go over here and I'm gonna click this next little check mark over there, which defines my first concentric phase, C1. I'm gonna hit plot of that. All right, look at this, look at this. Here is our plot of C1. So this, unfortunately, the color kind of shifts over. So now what was the E1 color is now the C1 color, right? But you can see that it just goes from here down to there, right? That's the concentric phase. For the concentric phase, you can see how much more activity we've got that right there, right? As soon as we have to turn it around and push it the other way, there's a whole lot more neuromuscular activity. Pretty darn cool. All right, let's add our next little data point here, okay? Up on this top row, this beautiful rainbow looking thing. I gotta tell you, just looking at this is just fun and cool. But what we're seeing here, this is the decomposed signal. So you take this thing right here, which is just the composite signal, all of the motor units saying, hey, this is what we're doing. We got more activity here, less activity there, more activity here, less activity there. Well, this is actually showing me differences in firing rates of individual motor units. Here's how you need to read this. Each one of these lines, each one, this little guy right there, and that one, and that one, and that one, each one of these colors, each one of these lines, they represent one motor unit, okay? And this is the firing rate of that motor unit over on this axis. So here's the time, here's the firing rate. So for these red guys, you could say that they are firing at a higher rate than these purple guys down here, right? So if we go to our eccentric contraction, all of the motor units from the red all the way down to the blue are firing a little bit less here, right? Okay? The blue guys, as a matter of fact, might even drop off to nothing, but these red and orange and yellow and green guys don't, okay? Then on the concentric phase, there's a sharp increase in the firing rate, as you can see right there, right? It kind of goes up for everybody across the board. And then, you know what, let's add another eccentric and another concentric. I'm gonna shade those, watch what happens now. Pretty darn cool. Look at that, right? Look at that. So even for the next eccentric phase, we have the same thing. There's a decrease, right? There's a decrease in what is happening with the firing rate for the red and the yellow and the orange, and a decrease for the green, and some of the blues and purples might actually almost drop all the way down to 0 right at one point, but these guys sure don't. I would say the vast majority do not drop to 0. It seems to be a minority of the motor units that drop to 0 here, right? Just keep this in mind, keep this pattern in mind. And this extends all the way out to the end of this set, okay? And if we just look at this, we just eyeball this, we can see that, yeah, it backs off right there, but it gets really bushy, backs off, gets bushy, backs off, gets bushy, backs off. Never goes to like nothing, right? If you look all the way over here, that's what nothing looks like. When there's just exercise over, we're not doing much, we're not doing any more presses, right? I still have the sensors on me, but the pectoralis major is relatively not doing much at all, okay? Kind of cool stuff. Now, what I want to do now is I want to actually compare the EMG data, for the raw EMG data from the pectoralis major to the anterior deltoid, All right, so what I'm gonna do is I'm gonna scroll down here. I'm gonna find my anterior deltoid right there. I'm gonna click that box and I want to plot that. Okay, now let's look at this. So remember, this is our first eccentric phase right here. That's less bushy than the concentric phase and gets even less bushy as I get close to the bottom, right? Right here, look what happens though with the anterior deltoid. It gets bushier as I get to close to the bottom. So it's as if the anterior deltoid is taking on the responsibility of putting on the brakes at the bottom, right? And then right at the beginning of this concentric phase, right, where I get a big push from the pectoralis major, I start to get a push from the anterior deltoid as well. They work synergistically right there, right? So what I'm seeing here is that this anterior deltoid seems to be putting on the brakes at the end of the eccentric and jumping in with that pectoralis major at the beginning of the concentric to get this load moving in the opposite direction, okay? Going through that concentric phase. And we get the same thing if we look at the next eccentric phase. Backs off in the pectoralis major, we get a little bump in the anterior deltoid as it's slowing everything down, and then another bump in the anterior deltoid with the pectoralis major as we turn around for that concentric contraction. Pretty darn cool. This is what happens at 65 pounds during my warm-up, and then I want to show you also what happens at the same with a heavier load, right? Heavier load, I think 75, 80 pound dumbbell, something like that. Let's check that out. So that was the warm-up. Let's go to trial number 3, and I will show you this one. I'm gonna hit plot. Bingo. Here it is, okay? So with a heavier load, as you can see, the length of the rep increases a little bit, right? Slightly longer time to do a repetition. But we see the same pattern, okay? So here's, again, is the eccentric, here's the concentric, eccentric, concentric, okay? If we look right here, yep, we see a decrease in what's happening in this pectoralis major and that big old bump right there as I go through the concentric, decrease on the eccentric, big increase on the concentric, and I want you to look at something right here now. Now that's really cool. You see how this little tiny difference right in there? Let me see if I can zoom in on that for you. Go like that. Yeah, I got that. Yes. I want to zoom right in on just this little part, because I want you to see that right here, we're actually starting to see where this pectoralis major is also helping to slow stuff down at the end of the eccentric, right? As well as turn things around for the concentric, right? In previous reps, we've seen something where it looked like the anterior deltoid was carrying all the load there. But now we're starting to get either enough load, maybe a little bit of fatigue. We're starting to get a change in the way this pectoralis major is helping out this anterior deltoid down there in that position. That is pretty darn cool. So let's go and grab our anterior deltoid now and look at it in the same position. All right, so now we're looking at the anterior deltoid for this third trial with a heavier load. I believe, 75 or 80 pounds with the dumbbells. And we know we got the same pattern here with the pectoralis major, and we got a similar pattern with the anterior deltoid, right? Where it kind of backs off on the eccentric, but then we have this big push right toward the end, and then a big push in the concentric, but it seems like that little push comes just a little bit later, right? Like the pectoralis major is a heavy lifter at the beginning of the concentric, and then just a little while later we get a bit of a pulse from that anterior deltoid. So we get some synergy, a little bit of handoff between this pectoralis major and this anterior deltoid, and this seems to be a little bit more pronounced with the heavier load than with the warm-up load, right? This little blip right here, that little blip right there. But in both circumstances, on the eccentric contraction, we always have the anterior deltoid seeming to really do the bigger work of deceleration, of slowing that dumbbell down as I'm getting down to that 90 degrees of abduction position, okay? Kind of cool stuff. Just so you can see this too, this gets pretty interesting. Let's look at the SMO2 data for this. Now, SMO2, you're gonna see well, let's just pull it up. Okay, let's see. We're gonna go to SMO2 right there. And let's check it out. Let's see what this data looks like for this. All right, so The concentration of oxygen in the muscle starts off somewhere up here at 75, or so percent, and it starts to drop down. As you can see, it gets all the way down, geez, darn near close to zero, right? As I'm getting toward the end of this set, right? It's just dropping steadily. So we can already see that this is 30 seconds over here. All right, we can already see that well within the first 5 seconds, there is a decrease in SMO2. Let's move on to looking at what happens as I go through full range of motion, okay? So to review, let's get this anterior deltoid EMG in here. There it is, plot that. As I go through the eccentric phase, there's a decrease in the EMG activity for the pectoralis major. To a certain extent, there's also one for the anterior deltoid, only to go up as I get deeper into that eccentric. Okay, and then there's an increase in both the pectoralis major and the anterior deltoid as I go through the concentric. Both of these guys, though, never really back off to like nothingness like this way out here on the extreme that we see over at 35 seconds and beyond. Okay, now let's look at what's going on with full range of motion. So what we're going to look at first is we're going to look at this. Let's see, let's try that again. We're going to look at this without the little shaded sections. Okay, what do you notice right away? So let's review this again. This is the eccentric, concentric, eccentric, concentric, eccentric, concentric, eccentric, right? You got that same pattern there. What do you notice here? I'm going to go up to this EMG. Look at this. Look at this. Nothing. It drops down. It drops down. We have these little gaps in here. Little gaps, little gaps. And if I go up here to the rainbow colored things, remember how with the other two trials, the red never went down to zero. It dropped down, but it never went down to zero like this. We have some serious drops in the firing rate of these motor units, right? Drops all the way down to zero, 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 dropping way down. Oh, this one that didn't right there. There's another one that didn't right there, but then it drops down to zero, pretty close to zero again right there, zero, zero, and zero, okay? That's pretty interesting. Now, let's identify where these little gaps are. Where in the concentric versus eccentric phase are these gaps, okay? So what I've done is I've labeled these things. Let's go through here and we're just gonna look at the different gaps. Say a gap right there, and there's another gap right there. Yes, okay, so let's plot these gaps. Let's plot these gaps, highlight the gaps. So there, I'm going to call that G1 and G2. And if you notice, it is toward the end of the eccentric contraction. It's toward the end of the eccentric contraction. As you drop below that 90-degree point, right, that pectoralis major, its activity drops off precipitously. The firing rate drops down to close to zero. All right, drops way down there. And it happens as I get further into that eccentric load. Now, something's holding the bag down there. Something is doing the work down there, right? Let's actually add now, let's go down here and let's add let's grab the anterior deltoid EMG. Let's put that in here, okay? Anterior deltoid SEMG right there, bop, and plot that. Look at that. So right where you've got this gap, this anterior deltoid, it's still fired up. There's no gap there, right? There seems to be a gap in the firing and in the neuromuscular activity of the pectoralis major at the end of this eccentric, but that anterior deltoid is doing something. It is doing quite a bit of work back there in that position, okay? Not as much as it does in other parts of this range of motion, but it is the only thing holding the bag down there. All right, now let's add all of the other, let's do the concentric and concentric 1, or excuse me, eccentric 1 and eccentric 2. I'll plot those two. We see we have the same pattern here, right, where the pectoralis major drops off a lot in terms of its behavior, its activity, and the anterior deltoid drops off, but then it starts to increase as we're getting down towards the end where it's slowing things down, right? And then it drops off again as we get all the way down to the extreme Why is that? Maybe it's because we have some elastic tension that's built in there that can help us get off the floor. That could be part of it. Might have some other synergists that are helping there as well. Okay? Like, it would be interesting to see what's going on with that long head of the tricep. To see how that's managing the elbow. Yeah? All right, let's add this, let's add C2, C1 and C2, concentric phase. And we see our same pattern there. We have that burst of activity here and then a big burst right in there. Okay, same thing here, burst and two big bursts right there. All right, so if you had to say, what is happening as I start to go into that full range of motion? That anterior deltoid seemed like it was just doing a whole lot of work the whole darn time. Pectoralis major, however, seemed to bail out way down in that deep position. Am I saying that's a bad thing? Not at all. It might be entirely load dependent, right? In other words, I can't do something where I'm challenging my pectoralis major and then just handing it off to my anterior deltoid, right? If I want to challenge my pectoralis major the entire time, then I'm going to have to limit my range of motion. If this is more about just shoulder range of motion, then I'm going to have to limit my load based on what the shoulder can do, right? Not based on what the pectoralis major can do, because it's not part of the game back there. Are you with me? All right, so I can't tell you what's better and what's worse, but I can absolutely tell you that for this individual, as we went through full range of motion, there's a difference in the way the neuromuscular system recruits the anterior deltoid and the pectoralis major. That pectoralis major does not seem to be doing very much at that extreme of the range of motion for this dumbbell press. And if that matters to you, and if that matters for this individual and for their goals, you got to do something about it.